Okay, so in this video, we're going to take a slight pause on talking about Mercury per se to introduce a new tool or a way of looking at something, and then we'll move back into Mercury. And so this video is about timing in astronomy, as you can see here, and think of it as sort of as a tool you'd use in astronomy, say, well, to do some timing, as we'll see. Let me just show you what I mean by this. Okay, so the way we're used to thinking about timing in astronomy is like this. So here's the sun here, and here's the Earth. And of course, as we know, the Earth goes around in its orbit. Something like this. And there's a few things we know about this. The first thing is that one orbit for us is what we call 1 year. And of course, one rotation is what we call 1 day or 24 hours. Okay, no big deal so far. All right. So let me talk to you then about this number right here, how we sort of classify that one rotation is 1 day or 24 hours. Okay, sort of goes like this. Suppose that you're on the Earth then, and maybe you're standing here like this on the Earth, and you look straight above your head like that, and what do you see? Well, you see the sun. And so in a configuration like this, you might be familiar with this from some of the activities that you did outside. This time for you right now would be 12 noon, right in the middle of the day. Again, why do we know that? Because you're looking up above, the sun's sort of high in the sky for you, not right above your head. Remember a few nuances about that. The sun is never above our heads unless we're somewhere between the Tropic of Cancer and Capricorn, and then there's at least a chance of that happening, but of course we're not. So we won't say right above our head, but we'll say nice and high in the sky. And I hope you don't get too confused about things like that, but that's normally what we just sort of associate as 12 noon, the sun nice and high in the sky. So what happens then is in order to sort of time one rotation, or this 24 hours here, what we do is we know that the Earth is, of course, rotating around its axis. So say this was the North Pole right here, and we're looking down on the whole operation, then you could imagine then that maybe the Earth is rotating like this, okay? And so what will happen then is the little person, a little bit of time later, I guess let me maybe draw the person in gray to indicate them riding along with the Earth. Might be here, then might be here, then might be here, and then at some point gets over here. Again, not because the person's moving, because they're standing on the Earth and the Earth is moving. And then they might be over here, something like this, and then over here, and then they're back again. And then, so let me just trace a few of these positions here so we just make sure we know what we're talking about here. A place like this might be sunset, because remember we're starting to get into the horizon and things like that. Can you guess what time it would be over here? Yeah, it'd be midnight over here, and somewhere maybe like over here might be sunrise, because again the horizon starts to kick in, the sun starts to come above the horizon, that kind of thing. But so we go through sunset, midnight, sunrise, sort of as we go around. The Earth rotates, and then what happens is at some point, I'll stick with the gray for a minute, I'll try and draw it right next to this original person right here, is that at some point what happens, I get this to behave, there we go, the gray person is sort of back in this position again, and of course they see the sun at the highest spot in the sky again. So it's noon once again for us. So maybe let's draw that in noon right here. We'll say it's 12 noon, but in this case I'll say again for this gray person right here, where the first 12 noon was for the green person that sort of started us all out. Okay? And so that you're probably used to, and you shouldn't have any trouble for this, but basically the way we do timing right now is we say noon to noon is 24 hours or 1 day. Okay, I'm going to put an asterisk up here for a couple of reasons, because for some technical reasons which maybe we'll get into in one of the very remaining final videos of the class, it's not quite 24 hours and it's not quite noon to noon, but we're not going to worry about that. Let's just go with noon to noon and 24 hours now to get our point across. So I hope you get that. And that's what we call one day, of course, here. And this is also, by the way, how we set all of our clocks and watches. Why do we do that? Because we like our clock. If you have a wristwatch on, and this is the 12 right here, we like the hands to be all nice and lined up at 12 like that. We like it to be at, so this is what we like to call noon. And when we look at our wrist and see 12 noon, we like to look up in the sky and see the sun at the highest point in the sky. That's just the way we like to live. Okay. Likewise, if you watch something like this, there's a 12 and there's a 6 p.m. We like to look up and see the sun kind of setting in the sky and that kind of thing. It's 6 a.m. and midnight, all those things, That's how we like to set our clocks and watch. And so it's no surprise then that this is called solar time. Okay? Noon to noon of the sun, 24 hours, one rotation. And we like to set our clocks and watches that way so that our clocks and watches are sort of synchronized with the sky and things happen when we feel comfortable with them happening when they actually do. So just my closing thought on this. For example here, when our watch reads 12 noon, we do not want to see a sunset, do we? No, we don't. We want to see the sun at the highest point in the sky. We want to go out and get some lunch. Okay, so in the next video, I will tell you about another timing method that there is in astronomy.